Alright, what is the pH of 0.3 moles per liter of pyridine? Pyridine is this base. When you put it in water, it steals a proton from the water and leaves an OH behind. So we got the base and its conjugate acid. We're only putting in pyridine, and then we're letting it equilibrate from there. They gave you the Kb. Now, there's a shortcut for this kind of question. When you're only putting in the reactant, pyridine, K equals x squared over the initial concentration minus x. If we did an ice table with our C5H5N and our water and our C5H5NH and OH minus, our initial concentrations would be 0.3 for the pyridine and 0 across the board. We'd be losing pyridine, gaining the conjugate base, and we'd have these concentrations at equilibrium, where X is the concentration of OH minus and of the conjugate base. Using our K formula here, it's products over reactants, X times X over 0.3 minus X. There we go. So, turns out what we have here is 1.9 times 10 to the negative 9 equals x squared over 0.3 minus x. Notice that all this comes from the ice table. But if you know the shortcut, you can just jump straight to it. I think this is a formula on your formula sheet. So, how do you solve for x here? Well, K is really small. I'm going to guess that it's insignificant. That makes it a little easier to solve for x. I can undo division by 0.3 by multiplying by 0.3, and I can undo the square by taking the square root of that side. When I do that, I end up with x equals, let's see, 1.9 times 10 to the power of negative 9. Don't forget to times it by 0.3, and then take the square root of it. I get 2.38 times 10 to the minus 5. That's the concentration of OH minus. So, to get the POH, I just take the negative log of that number. Log, and then negative it. 4.62. Sweet. We're almost done. They asked for the pH though. The pH, you take 14 minus the POH, and you end up with 9.38, which makes sense if you're putting a base into water. It's a basic pH. Check it out. Hopefully it's quick. You don't need an ice table if you use this formula. You can assume that X is insignificant because the K is really small. Solve for your X, take the negative log to get your POH, and then subtract that from 14 to get your actual pH. Hey, best of luck to you in your own calculating the pH of a base in water questions.